Hello everybody, welcome back. This is Mr. Kusaj, and we're up to chapter 1-6, function operations and composition. So part 1 will be function operations. By operations, we mean what you think we mean, adding, subtracting, multiplying, dividing. So we want to do that, adding, multiplying, dividing, subtracting, with functions. Suppose you had two functions. Let's call them f and g, f of x, g of x. Well, if you want to add the two functions, we would write in notation f plus g in parentheses of x. So what that means is a new function that's made up of the two old functions added together. Well, how do you do that? Well, just like you would think, you take each function and then add them together, right? We'll see that in we'll see an example for each one of these. The difference, subtracting, again, you write it like this: f minus g in parentheses of x. And how do you do that? Exactly what you would think. The first function minus the second function. There's the product, multiplying. Again, exactly what you would think. One times the other. Quotient, dividing. Right? This is the way you write the result. How do you do it? You take the first one, divide by the second one. Okay? So let's do an example of each one. Notice that in the example, I'm asking you to do two things. You're going to find the function, right? We're doing the operation, and then you're going to write down the domain. So here are the functions we're going to work with. Here's f, here's g, here's h. So in the examples, I am going to ask you to add, multiply, divide, subtract any two of them. So I'm going to do one for each. So let's start with the sum. Can you find f plus g of x? See, now you're supposed to know what that means. That means you take the two functions and add them, side by side, and add them. So f of x is x squared plus 4x, right? G of x is square root x plus 2, so you just add them. Right? Now before you leave, you should try and simplify if possible, but as you can see in our answer here, nothing can be simplified, so we're done. This is our new function. We found f plus g of x. There it is. Okay? Now we also want the domain. So remember, for the domain, we really only have to worry about when we have fractions and radicals. Fractions can't have 0 in the bottom. Radicals can't have negative on the inside. Oh, look. X is fine here, but we cannot have a negative come out to here. So what would make the inside of this radical negative? Negative 2 for x would make it 0, and 0 is fine. So when you get lower than negative 2, like negative 3, negative 4, negative 5, negative 6, plus 2, that comes out to negative. So it seems like negative 2, you can look at it like the borderline. Anything over negative 2, including negative 2, is okay. Anything less than negative 2, not okay. So let's write that down. Isn't that simple? Right? From negative 2 upwards to infinity is okay. And we include negative 2, because that would make it 0, and 0 is okay. Below negative 2, you'll get negatives, and that's no good. So our domain, the x's that work, are right here. Okay, 1 down, 3 to go. Here, I'm asking for the subtraction. Find the function f minus h of x. How do you do that? Well, you take f of x minus h of x. Okay? Now, here's a mistake that I see very often. Here's f of x. Here's h of x. And people will write this minus this. But we're saying minus the whole function, minus all of h of x. So that's why you need to put parentheses. It's minus the whole thing, not just minus 3x. minus the whole function. That makes a difference. So now you have to distribute the negative. So it's minus this. So you get minus 3x minus 5 is plus 5. This is the function. Are we done? Not quite, because we can see that we can simplify something here. So go ahead and simplify. So the 4x minus 3x in the middle there, they can combine and make 1x. Okay? That's the function. That's the f minus h of x function. This is a new function. Okay? Now, what is the domain of this new function? Well, I got no fractions, no radicals. That means all of the x's are okay. Negative infinity to positive. Everything is okay. All right. 2 down, 2 to go. The next one is multiplication. Okay? There you go. I'll stop moving. There it is. So here I want you to find a function that's f times h of x. So we're going to end up with a new function that we get by multiplying f and h. So definitely need parentheses here, right? Right? That's f of x, that's h of x. Now, do you remember how to multiply binomial times binomial? 2 parts times 2 parts? Maybe your teacher showed you with the box. The FOIL method first, outer, inner, last, FOIL. Okay? So you can ask me in class, but I'll do it really quick. Right? X squared times negative 5. That's the outer. Let's do the first. X squared times 3x is 3x to the third. 4x times 3x, that's the middle, 12x squared. X squared times negative 5, that's negative 5x squared. And I put those here so I can combine them really quick, save space. So the middle comes out to 7x squared. And then the last comes out to 4x times negative 5 is negative 20x. Okay, I did that really fast, a lot of talking, but all we did was binomial times binomial. Okay, if you've forgotten how to do that, ask somebody, ask me, whatever. Okay, what is the domain? Hey, look, again, we got no fractions and no radicals to deal with, so x can be anything. That was easy too. Last one. The last one is the division, the quotient. So I'm looking for h over f of x. How do you do that? H of x over f of x. Okay? Those are the two functions. Now what? Can I simplify? I'm looking. No. Well, wait. I can simplify here. I can take out an x. Right? So I can factor this and see if I can cancel top and bottom something. Nope. Even though I factored, I still cannot I cannot cancel anything. So this is as far as I can go. That's it. But wait, we need the domain. Notice that I have no radicals, so I don't have to worry about negatives, but I do have a fraction, so I have to worry about zeros. When is this long denominator going to be 0? Well, if you make x 0, 0 times this, that'll make it 0. So x is not allowed to be 0. We don't want x to be 0. So 0 is not part of our domain. What else will make this 0? Negative 4 here. Negative 4 plus 4 will make this 0. 0 times x is 0, and you'll get a 0 in the bottom. So we don't want negative 4. Negative 4 is not part of our domain. 0 is not part of our domain, and negative 4 is not part of our domain. Everything else is fine. Let's write that down. Whoa, what the heck is this? Well, this is one way of writing it. So everything from negative infinity to negative 4 is good, but not 4, not including 4. Union together with negative 4 to 0, but not including 0, not including negative 4. And then from 0 to infinity. That's good too. You think that's too long? Well, you could have chosen to write it this way. Remember this? Set builder notation. X such that X is in the real number set, comma. So that means all of the real numbers, but X is not equal to 0, comma, and X is not equal to -4. So this is another way of writing the domain. Okay? That's it. Let me leave you with one try problem. Go to your book, page 58, and try problem 1A. Okay? At least copy the question and write down, start the answer, and go as far as you can, and we'll talk about it in class. Okay? That was less than 11 minutes. Pretty good. All right. See you in class. Bye.